All right, hello everyone, this is Mr. Crozier. This is set E. I'm going to give you help on problem 11 and 52. Problem 11 right here is a velocity acceleration problem. Has the information there. So what you want to think about on these problems is position to velocity to acceleration, and it's just derivatives. You take the derivatives down, and if you want to go back up, we do the opposite of derivatives, which are antiderivatives, which are integrals. So we can, on this side, we can take derivatives, which is d dx. On this side, we can take integrals back up. All right, so we have the situation where the initial velocity is 96. The acceleration at any point is negative 32. What is the time to max? What is the max height? Well, first off, let's go ahead and talk about the equations. Here's my acceleration equation. Sorry, I need to go back. Here's my acceleration equation. The acceleration for any time is negative 32. If I integrate both sides, if I integrate acceleration, I get velocity. And if I integrate this, I get negative 32x plus c. All right, so there's my velocity function. But I know something about velocity. This tells me that at velocity 0, the output is 96. So at velocity 0, the output is 96. Solve this equation for c. Well, that's 0. 96 is c. Can't get any easier than that. So my equation is the velocity is negative 32x plus 96. All right, and that's awesome. So now we have a velocity equation. Well, let's just, for the fun of it, let's go, and this is what you're going to use to solve most of the problems right here, but just for the fun of it, let's go ahead and go one step further and say, what is the position? Well, the position here would be, I add 1 up here, so I'm at 2, and then I take this and divide it by 2, so that'd be negative 16 plus 96 if I integrate that, and plus c. I have to put an x right there. So if I integrate this, there's my position function. So what is this graph? Well, first off, if I need the c value, but I can't find the c value because I have no other information that's going to help me. So I can't figure out what this is, but we do know what this looks like, right? It's a parabola that's upside down, so it goes up and it comes down, and that's what the position is. This is a position graph, not velocity, not acceleration. This is a position graph because it's an upside down parabola. All right, well, now that we have that out of the way, we don't know where it starts though, right? We don't know what the constant is. It's somewhere in here. But now we can answer these questions. Question A says, how long will it take the ball to reach its maximum height? Well, here, we're going here, 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 and at this point there's some maximum height here. And how did we do that in the past? Well, that maximum height is when the velocity is 0. So if you set the velocity equal to 0, and you solve this equation now, you solve that equation, and you will get x is equal to 3. So after 3 seconds, 1 second, 2 seconds, 3 seconds, 1 second, 2 seconds, 3 seconds, we're at our max height. All right, because we've used the derivative, found when the derivative is equal to 0. Remember, there's a tangent there, it's equal to 0. Now, what is the height there? Well, we can't plug that 3 into the position function, right? Because we don't have a c value. But what we can do is we can integrate it. Let's call this, we can do the integral from 0 to 3 of that acceleration function. And what that's going to do is give us all of this area here, and we don't need the constant to figure out the change in height is what we're talking about. How high up does it go? Doesn't matter where the constant is. So if you integrate this, and then this is where you have a calculator, just go to the math. That's an easy one to do by hand, but we have a calculator, so we might as well learn how to use it. 0 to 3 of negative 32x plus the 96 dx, 144. So 144 feet. So we found this velocity equation, used it there and there. All right, well, problem B. Well, after how many seconds is the velocity of the ball 1/2 the initial velocity? So after how many seconds? Well, let's see here. If we want to go halfway, here's our velocity equation. Velocity of time is equal to negative 32x plus 96. And we want 1/2 the initial velocity. So we want half of this. So I just put 48 over there. And solve that equation, because I want to find out not when velocity is 0, but when it's halfway, when the speed has decreased from here down to there. Solve that equation. It's fairly obvious. It's going to be 1.5 seconds. For part C, what is the height now? Well, 0 to 1.5. And you integrate this one. Should put the dx there. And I did it. And you have this. You can just go and change this. See, can I get back over there? Sure. 1.5. And it's 108 feet. And the thing to see here is this is exactly half, which makes sense. But this one's not exactly half, which does make sense too, because this ball is speeding up, and then it's speeding up but not so fast, and it's on a slope right here. So the halfway point, the areas aren't exactly cut in half. All right, 52. I want to explain 52 for you down here. 52. The problem is the profit. The marginal profit for a product is modeled by this. Change in profit, change in X, and X is the unit sold. So what is the change from 550 to 500 units? What is the change in profit? Well, let's see here. They're losing amount. They're selling less. They're probably selling less products. So 52. Function is here. If I went ahead and graph this, what would this look like? Starting at 20 and then going down. So this is a decrease here. And what is the change in profit from here to there? Well, it's a simple integration problem, right? I mean, if we have the derivative right here, all we have to do is integrate it. But be careful on here. We're going from here to here. Usually we go from usually our integrals are from 2 to 5, right? We're looking at it from 2 up to 5. Here we're going from 550 up to here, so the 550 is going to be up here, and that's going to be down there. So then we can just integrate it, math type, from 550 to 500, 20 minus 0.00. Oops, I forgot 1 0 on this one. X, and there's a change, which makes sense, right? They're losing money. If they're dropping the sales, if they're selling less items, well, the change is going to be that they lost some money right there. All right, so that should help you on those two problems. These are easy ones to integrate by hand, but your quiz coming up, you're going to have a calculator, so you should learn how to use the integral feature of a calculator.